Hello, my name is Guolong Zheng, a student from University of Nebraska-Lincoln. Today I'm going to talk about my work on debugging declarative models in Alloy. There are many existing works for imperative language debugging, for example, for C or Java, but because of the huge gap between imperative and declarative languages, it's hard to directly apply these techniques to declarative language. Alloy is a very popular declarative language which has been used to model many systems. The only line of work for debugging Alloy models is Alloy FL and A repair. Both work requires a set of tests. For example, a predicate describes an instance for a model. However, test is not very common used in Alloy because the Alloy developer usually write assertions or predicates to check the expected properties for a model. So in this work, I'd like to present a debugging technique for Alloy based on assertions and predicates. In my previous work, I have done a research. I have developed a tool for localization. That given given an assertion, I first check Alloy to see if there's any counter example, and then I would use a max set solver to generate an instance that is most similar to the counter example. And then I would compare these two and use the difference between these two to locate the error. And I tested this technique on 152 bugs, and it gives an average rank of 2.4 and an average time of 0.2 seconds. Now I'd like to propose a research for automatically repair Alloy models. Template-based repair is a popular repair technique that has been applied in many automatic program repair techniques. It first learns some templates from existing fixed patches, and then it would pick a template based on the bug features. And then it would instantiate the template with the variables in the program, and then they check if it fixes the problem. Because the different syntax and semantics of Alloy and other languages, it has been some challenges to apply template-based repair to Alloy. So the first one is that there is no bug taxonomy for Alloy. Like in template-based repair, like one of very popular bug type is non-pointer dereference, and the corresponding repair template is to add a pointer check before you dereference the pointer. But there is no such clear bug and templates information for Alloy. So I collect 152 bugs from Alloy FL and 935 bugs from Alloy for Phone to generate some bug and templates for Alloy. And the second one would be the problem of instantiating the template. For the imperative language, like the variable would just be the variable name in the context. But in Alloy, a variable would maybe a complicated expression. So instead of you just search for the variable, you may need to search for complicated expression to fill into the unknown host of a template. So the current work is still under implementation, but I already have some preliminary results to show. And the first one would be replace arithmetic operators with integer arithmetic functions, like a minus b would be converted to a integer minus a and b. And the other one would be constrain out a relation by adding a new fact such like no x dot y. The third one would be add a condition to an expression. So for example, like the original expression a becomes we sense this as a new condition like x and use x to imply a. And that's basically my talk today, and thanks everyone.